All right, got to do some math here first, do some algebra first. Let's isolate the sine of x. So we got 2 sine of x equals 1. Divide by 2, so sine of x is equal to 1/2. All right, notice our restrictions. We only want to be for between 0 and pi. So in these two quadrants, where is sine positive? Well, sine's positive in both the first quadrant and the second quadrant, so we're going to have two answers here. All right, what family has sine of 1/2? All right, hopefully you said the 30-degree family, so pi over 6. All right, so in the first quadrant we got pi over 6. Not a good place to draw. Yeah, that's good. Pi over 6. All right, in the second quadrant, what do we got? We got 1, 2, 3, 4, 5. So 5 pi over 6 is our second answer. So x is equal to pi over 6 and 5 pi over 6. All right, we're going to have to factor this one. So think about this. Think about it as like 2x squared plus x minus 1. So what multiplies to give you -2, but adds to give you 1? So what is that? We're on a positive, so it's going to be 2 and -1. All right, so this is going to factor to 2x and x. I want a +2 and a -1. All right, in place of the x, we're going to put our signs back in. So this is 2 sine x minus 1 and sine x plus 1. All right, let's get rid of this. All right, so zero product property. I'm going to set 2 sine x minus 1 equal to 0. And I'm going to set sine x plus 1 equal to 0. All right, solve for sine. So I got sine x is equal to 1/2. And sine x is equal to -1. All right, notice I'm working on the whole circle here. The entire circle. From 0 to 2 pi. All right, let's figure out. All right, sine's positive. Sine's positive in the first quadrant and the second quadrant. So let's work on a sine of 1/2. All right, 1/2. What family is that? Well, we just got finished doing it. This is the 30 family, so pi over 6. So that means one of our answers is pi over 6. And then in the second quadrant, we're at 5 pi over 6. So our two answers are pi over 6 and 5 pi over 6. All right, second part of the equation. Sine x equals -1. Where is sine -1? Well, it's going to be down here, right? 0, -1. Our y value is -1. That corresponds to the angle 3 pi over 2. So our third answer here is 3 pi over 2. So we have three answers. Pi over 6, 5 pi over 6, and 3 pi over 2. Everything that makes those conditions true. All right, so now we're going to move to a different type of question. Notice the wording on this question says, write the general solution. That means it's going to have an n in it. We want it to go around the circle as many times as we can. We're not putting a restriction on it. So that means all of these answers are going to have an n involved in it. That's the number of rotations around the circle. That's what n is going to represent. All right, let's solve for tangent. So I got the tangent squared x is equal to 3. Square root both sides, so tan x is equal to plus or minus the square root of 3. All right, so let's look. We're looking at the whole circle first. So we got plus or minus. So we got to take everywhere that tangent is positive. So let's look at these two first. All right, what family has a tangent of square root of 3? It should be your 60 family. All right, so if we're positive here at pi over 3, and we're also positive here at 4 pi over 3. All right, let's look at those first. We want to write a general solution. So have I made n number of rotations around my circle, I would get to another answer. So let's start out. Look, how far are these two angles apart? What is that distance? Well, you notice it's a straight line, so that means it's pi. So that means I'm going to add a multiple of pi to this. So I'm starting at pi. So my first answer is pi over 3 plus n times pi. That'll get me to, so if I added 1 pi, n is 1, I'd get to 4 pi over 3. If I did 2, I'd be back up here, okay, with adding pi to this. So it's 7 pi over 3. And every time I add pi, I would end up back on another answer. So that's what the n pi does. Gives us all possible answers. All right, now let's look at the negative ones. So I'm going to get rid of this without getting rid of my whole deal here. Actually, let's just draw it over. Okay, let's go back. So now I need the negative ones. All right, so tangent is negative in the second quadrant and the fourth quadrant. All right, I've got my pi over 3. All right, so in the second quadrant, my 60-degree angle is going to be 2 pi over 3. And then in the fourth quadrant, it's going to be 5 pi over 3. Notice here again, these are pi apart. So that means I'm going to add a multiple of n pi. A multiple of pi, which is n, represented as n pi. All right, start with the smaller angle, which is 2 pi over 3, and we're going to add n pi. These are what we call general solutions. They're going to have an n involved in it, plus n something. And that depends. It's not going to always be n pi. It depends on the problem. And we're going to look at them all the same way. All right, find the general solution. All right, we got a factor here. Let's factor out a sine of x. So we're left with sine squared x minus 4. All right, this is difference of squares, so factor again. So I got sine x plus 2, sine x minus 2. Use a zero product property. So sine x is equal to 0, sine x is equal to negative 2, and sine x is equal to positive 2. All right, hope you got some warning signs going off here. Remember, sine can only be between negative 1 and 1, so these two are not possible. Not possible. There's no way we can get an angle that has a sine of 2. So that means we only have to deal with the sine of x. Okay, so let's think about it. What do we got? Where is sine 0? So where are the y coordinates 0? So we're here, we have 1, 0, and over, so at 0, and then over here at pi, we have negative 1, 0. So sine is 0 at both 0 degrees and pi. All right, I want a general solution. So how far away are these two angles? Pi. So that means we're going to add a multiple of pi. So n pi is going to be added to our answer. Take the lower angle, which is 0, and add n pi. So simplify that. So my answer is n pi. Okay. All right, we'll have to factor. So what multiplies to give you 4 and adds to give you negative 4? That would be negative 2 and negative 2. All right, so how's this thing going to factor? It's going to be 2 cosine x. And I want them negative, so it'll be negative 1, negative 1. So it's a perfect square trinomial. Well, it's the same thing twice. I really only need to set one of them to 0. All right, solve for cosine. All right, let's see, what are we doing? We want a positive 1/2. So cosine is positive in the first quadrant and in the fourth quadrant. All right, what family has a cosine of 1/2? So that's the 60 family. So pi over 3. All right, so we're at pi over 3 here. All right, and we're going to be at pi over 3 down here. So at 5 pi over 3. All right, now notice that these don't make a straight line. We're not pi apart anymore. So this is going to be a different multiple. So let's look at, so to get around, so we're going to have two separate answers here. So what is our multiple going to be? How do we get back around? If we start here, what do we have to add to get back to another positive angle in the first quadrant? We're going to have to go all the way around and add 2 pi. So that means our multiple is going to be pi over 3 plus 2 pi times n. So this is typically written as pi over 3 plus 2n pi. That's the way you're going to see it. But we're multiplying by multiples of 2 pi this time. All right, same thing with our 5 pi over 3. So how we're going to get back around to that angle? If we start, we're going to have to go all the way around again. So here again, we're going to be a multiple of 2 pi. So it's going to be 5 pi over 3 plus 2n pi. Both of these are my answers. Okay, so with the cosine, you're going to have to do a multiple of 2n pi for your general solution. Okay, a couple more problems. All right, let's solve for tangent. So I'm going to square root both sides, so I get the tangent of x is equal to plus or minus 1. Okay, let's look at all of these, because this is kind of a special situation. All right, what family member has a tangent of 1? And since I want the positive and negative, I want to be all the way around my circle. All right, 45 families have tangents. So I've got 45 pi over 4. I've got 3 pi over 4. 5 pi over 4. And 7 pi over 4. Alright, because we're going all the way around our circle, we can just have one equation to represent all 4 of these angles. So think again, how far are they apart? Well, 45 plus 45 is 90. So that's pi over 2. So every multiple of pi over 2, we're going to get to another answer. All the way around and keep on going forever. So that means my general solution is going to be x is equal to pi over 4, the smallest angle, plus multiples of pi over 2. So n pi over 2. All right, last question. Different type of question. If they tell me the arc tangent is 5 over 12, then I can set up, this is going to represent an angle, so I can set up the following triangle. And because it's tangent, I know that 5 is opposite and 12 is adjacent. Now, it's asking me for cosine. Cosine is defined as adjacent over hypotenuse. So that means I need to find my hypotenuse. All right, so hopefully you remember your Pythagorean triple. So the hypotenuse is 13. So now they ask us cosine. What's the cosine of this angle? Well, cosine is adjacent over hypotenuse. So the cosine of theta is equal to 12 over 13. So that's our answer, 12 over 13.